Good morning, boys and girls. This is the last video of chapter 10. It's 10.9. It's figures on a coordinate plane. Sorry if you hear some bouncing. Mr. Twisdale's playing some basketball in the gym. So our objective is I can plot polygons on a coordinate plane and then find the length of the sides. So let's go ahead and get started. Okay, so I honestly think this lesson is pretty easy if you feel confident in your ability to plot on a coordinate grid. Because all you got to do is plot the points and count the sides. And by counting the sides, what I mean is you're going to be counting boxes, okay? So, I'll give you a couple of example problems. If you would like to use some coordinate grids, I can print out some if you want to just glue them into your notebook. So let's go ahead and start on this first example problem. This will go on the left side of your notebook. The parallelogram is PQRS. Now these are the names of the points, and they make the sides, or the lines as well. I'll show you what that means in a second. Plot the points and connect the dots. P, Q, R. They did not give us the coordinates for S. We need to figure those out. Let's go ahead and pull out the marker here. So I'm going to start with P. P is at 4, 2. So positive 4. Remember, we're going over 4. 2, 4, and then up 2, 1, 2. I'm going to put a dot there, and I'm going to label it P. Okay, next is Q. I'm going to go over 3, and then down 3 because it's negative, right here. And I'm going to label this dot Q. Now, right here, I'm going to connect these dots. This has created the line PQ, and you're going to see that, and it'll have a line over it. That's saying, what is this line? What is the units there? Okay. Now we're going to go R is negative 3, negative 3. So negative 3 across, negative 3 down. Dot there. This is R. Okay. Connect these dots. Now, I need to know where to put S. You could probably guess it's going to go somewhere around here so that we can finish our parallelogram. But to find the exact point, let me show you what I'm going to do. I know that a parallelogram has the same base on the bottom as well as on the top. So if I count these spaces here, it'll tell me how long the length RQ is, and that'll tell me how long the length PS will be. So I'm going to count these. 1, counting the blocks, 1, 2, 3, 4, 5, 6. So the length of line RQ equals 6 units. So the length of P to S will also equal 6. So I'm going to start here from P and count backwards. I wouldn't want to go this way because that's going to give me a really weird looking parallelogram. So 1, 2, 3, 4, 5, 6. And this corner here, let me get my marker. Oh, I lost it. 1, 2, 6. Okay, that corner there should give me a full parallelogram. Now I just need to tell them what point that is. So it looks like it's, let's see, 1, 2, negative 2, positive 2. So S is negative 2, positive 2. Okay? And that's pretty much the most difficult problem we're going to do today. One thing you need to really recognize is that this length, sorry, I got distracted. RQ is represented by this symbol here. RQ with the line over the top, okay? And that was the length of the unit was 6 because we counted 6 blocks inside of it, okay? So PQ is this line here. Let's quickly, this is S. SP would be right here. RS would be right here, and then they have a line over the top of them. Okay, so let's go ahead and try another one. Now, you're going to see this word. This is vertices, or vertex, and that's the points or the corners of the triangle, the rectangle, the parallelogram, the square, the trapezoid. That's the vertices, okay? So, the vertices or the corners of the triangle ABC are A, negative 1, 3, B, -4, -2, and C, 2, -2. Then they're going to give us the instructions. Graph the triangle, okay, and find the length of the side BC. So you're going to get 2 points on a problem like this. First, they're going to look at if your triangle's graphed correctly. Then they're going to look at what is the length of the side BC. So let's go ahead and get started on this graph. I'm going to switch to a nice blue. Our A is -1, 3, so I'm going to go over to the left, -1, and up 3. That's A. Here I have B, -4, -2, over -4, down -2. There's B. I'm going to connect these dots. And C is 2, -2. So again, if you feel pretty confident in coordinate grids, then this lesson is probably super easy for you. Alright, so I've graphed my triangle ABC, and you'll notice that the reason they call it the ABC triangle is because the sides are A, B, and C. Okay, and I need to find the length of the side BC, which is the side connecting B to C. To find it, I'm just going to count the squares. 1, 2, 3, 4, 5, 6. So the line BC equals 6 units. Easy as pie. There's our 2 answers. We have our graph and we have bunnets. It looks like thus will say 6 units. BC equals 6 units. So, you ready for the next one? Okay, here's another example, and then I've got some try it problems for you. The vertices of the triangle DEF are D, -2, 3, E, 3, -2, F, -2, -2. Same instructions, graph the triangle and find the length of the side DF. If you feel confident that you know how to do this, go ahead and pause the video and do it. Then check your work. That's a great way to check your understanding of this lesson so far. I'm going to go ahead and solve it now. I'm going to start with graphing D. Got -2, +3. That's D. Remember, always label them. Looks like a P. 3 over 3, down 2. This is E. Remember, I'm making the shape of a triangle. And F is -2, -2. There's F. Connect my dots. Okay, so far we're halfway done. We've graphed the triangle. Now I just need to find the length of the side DF. So I need to first find DF. This would be DE. This would be EF. This line right here would be DF. Now I count the squares. 1, 2, 3, 4, 5. So the line DF equals 5 units. Or if they'd be inches, if you were using a map or whatever, it would be maybe miles. But if it doesn't say, then just call them inches. Or units, sorry, units. Alright, sometimes you'll be graphing things like a trapezoid or a rectangle. We happen to have 2 triangles. This one has 4 points to it, so it'll be different. Here's a try it problem. You're going to graph the figure, so the shape, and find the length of the sides BC. So here's your 4 points. A is 1, 4, B is 1, -2, C is -3, -2, and D is -3, +3. Go ahead and pause the video and try it. And then I'll solve it with you here. Okay, so I'm going to start with A is 1, 4. I have 1 and up 4. Here's A. B is 1, -2. I'm going to go over 1, down 2. C is -3, -2. Over -3. Oops. Down 2. And D is -3, +3. Oh, look at that. This time we have made a trapezoid. It's not quite a parallelogram, but it is a trapezoid. Okay, so I'm going to label that. This is a trapezoid. Because you'll notice that here from A to, oh, I forgot to label my sides, sorry. And there we go. from here A to D, you'll notice it's not straight across, but it does swoop down, giving us a shorter base 1 and a longer base 2, making it a trapezoid. Okay? Alright, so they need to know the length of BC, so I've got AB, I've got BC, there's my line that I'm looking for. Count my units, 1, 2, 3, 4. So, the line BC equals 4 units. And there's your answer. Okay, hopefully you got that one correct. One more graphing problem for you. Same instructions, you've got different numbers at the top here. These are different, so go ahead and try again. You have a length of BC as well. And just a hint, these may or may not be on your homework, so I would definitely check them out there, okay? Okay, go ahead and try this one. Alright, let's solve it here together. A is -1, +4. Put a dot. Now, if you totally get this and you're like, wow, Mrs. Twisdale, this is really easy, then I want you to try doing the enrich page because it looks kind of fun. So, if you got this stuff, do the enrich page. And if you need a different, or if there's not enough copies of the enrich page, let me know. I've got 5, 1, and -1, and +2. And that's line D. Oh, looks like we've got a nice rectangle here. Looking for my side BC. Units 1, 2, 3. So BC equals 3 units. All right. Any questions, let me know. And the last is I want you to explain how you would find the fourth vertex of a rectangle with vertices at 2, 6, -1, 4, and -1, 6. So I want you to explain that in words, and when you check off your work with me, come show me your answer and I'll discuss it with you. Or if you talk to Mrs. Howe, that's fine too. Okay, and that's our lesson for today. Hopefully the basketball in the background wasn't too distracting. And I hope you guys have a wonderful day of learning. Make sure that if you have any questions, you ask them to me because this is the last lesson in this chapter. Good luck on your work. Thanks. Have a good day.